Okay, free response question number 3. Daphnia pulicaria is a water flea, a small crustacean that lives in lakes and is a major food supply for many species of fish. When fish are present in the lake water, they release chemicals called pheromones that induce water fleas to grow long tail spines and make them more difficult for the fish to eat. One study in this phenomenon compared the relative length of tail spines in Daphnia pulicaria when pheromones were present to when they were not. Below are data on the relative tail spine lengths measured as a percentage of the entire length of the water flea. And here's your data here. Sample size, 214, 152, large enough sample size, we're good. Sample means for the pheromone present versus non-pheromone present, and the standard deviations for each. And notice that there is more for pheromone than not, so there is cause to run a test. Do the data provide convincing evidence that the mean relative tail spine length of Daphnia is longer in the presence of fish pheromones? Assume the conditions for inference have been met. So let's first focus on this. Convincing evidence test. 2 samples means it's a 2-sample t-test. And so we're getting it for the difference, right? So that's what we're doing, a 2-sample t-test for the difference in means. So here's the write-up for that. So this first part is just going through that 4-step process. It's a 2-sample t-test for the difference in means. We define what the difference is. And I said it was the true difference in mean relative tail spine length when fish pheromone are present or absent. Next, identify my hypotheses. So the null would be that the difference is 0. The alternative would be, since I'm doing present versus absent, and I'm subtracting that, that's a positive difference. So that alternative is going to be greater than 0. And let's talk about the conditions. This one's kind of nice. It says the conditions have been met. Right there, assume the conditions are met. Where does it say that? Oh, that's in the previous problem, right? Assume the conditions are met. So all we got to say right here, conditions are assumed to be met. So let's run the test. So we're going to run this in our calculator. We don't have to report anything outside of what our calculator says. So we're going to run this as a 2-sample t-test. So stat tests 4. You can go to stats, and you're going to enter in every piece of information. So our X bar 1, 37.26. SX1, 4.68. N1, 214. X bar 2, 30.67. And I got to go back and put that 6 after the 2. SX2, 4.19. N2, 152. Everything should look correct there. Double check that. Enter those in your calculator yourself. This is a greater than. So make sure that's greater than. Never select pooled. And go down to calculate. And here are our results. We gotta report T, your p-value, and degree of freedom. You don't have to write in any formulas. Your T is 14.12. Your p-value is p right there, 2.4 times 10 to the negative 36 power. You can say it's approximately 0. And your degree of freedom, just report that right there, 345.08. Now let's make a conclusion. So we run the test, we identify the test, say we use technology, make our conclusion, report these 3 values, and compare it to your alpha. So our alpha was 5%. Because our p-value is almost 0, when it's compared to alpha, it's much smaller. We reject the null. We have convincing evidence to conclude the mean tail spine length is longer when fish pheromone is present. So what additional information do we need to confirm that the conditions for this test have been met? So let's go through the problem and see if we can figure out what's not stated. We have a large sample size, so n is greater than or equal to 30 for both, so we're good on that. We don't know how many of these I guess fleas, water fleas are present, so we're not sure if we met the 10% condition. And it doesn't say anything about random samples. So here's what we got going on. We have a large enough sample size, so we got that, but we need to know if our subjects were randomly selected and if our sample sizes were less than 10% of the population sizes. Probably have been met since the previous problem said they were met, but we would need to know that random, and then we'd have to meet the 10% condition in order for us to proceed.